Welcome and thank you for coming to talk about my internal internship. Today I'm going to discuss my work experience for the OCS department. During this time, my supervisor was mostly Justin, who was very supportive and understanding and let me ask a bunch of questions that I asked at the time. First of all, before this, I had my external internship, so I took this out of sync. I want to explain that because I felt that having taken that, I would be better able to help, that I would be able to help the internal internship a little bit better. And that with this, I would be able to help the OCS department a little bit better with that. And come to my surprise that I wasn't really, it's two completely different fields. At ETC Computerland, I mostly worked on hardware, like setting up computers, which we did in the OCS department. But I also worked more with viruses and installing stuff, that type of stuff. But here, we mostly ran cables, made cables. It's felt more as a network administrative job than more of a tech job, which I really came to like a lot. And one of the things that really shocked me about that was one of the first few weeks that I was working here is that we actually had to run cable in the Carroll Missions Center in the basement. And that was like the first time that I ever ran cable before. And it really opened my eyes to how little I actually knew about that world of computers, and that to be more valuable in the workforce, I needed to keep learning about this type of job. Another point that I had is to be honest about my physical disability that I have. I had a stroke when I was born, and it makes it very hard for me to lift certain objects. And I tried, it's a very private issue because it's not what really defines me. I try not to have it define me because it's not really who I am, and I like to keep it private. So, but that being said, I had to carry a lot of things my first couple weeks. Different computers, paper this way and that, and I felt that after a while I would come home and I would be completely sore, and that's not good. So I didn't know how to tell somebody that in the OCS department because I really wasn't sure of how everybody would handle it. So I've had people overreact, I've had people not take it seriously enough. So I went to Ms. Todd for help on how to handle this situation, and she kind of acted as the third party between me and Justin to help. And after that, we had really no problems. I was able to use a cart. They understood that I couldn't lift as much, so I would do other jobs. When times were less busy, I also learned a lot because we worked on setting up the Windows deployment server and getting that whole rack set up, which I got a lot of practice making cables, tons of time making cables. And half of them I did not make well, but the practice was there. So I'm glad that we had that off time that I could practice those skills that are really important in the network. The other part of my project, I had to complete a 40-hour project building a robotic arm that could pick up a glass and try to pour it. For my demonstration, I didn't use water, but marbles, because the first time I did it with water, it kind of turned into a giant mess. So I decided to go with marbles because marbles kind of act the same way as water is. They take the path of least resistance in most cases. So I used Lego NXT parts, which I have never used. This whole project was new to me, and I got it from Ms. Todd. We came up with the idea that she wanted a robotic arm that could move and that the lab could use for different purposes so that other people could experience it and try to learn from it. During these steps, I learned Well, while working on this project, I used steps that I used when making my Blender projects, which is I research the topic, design a prototype, test the design until it's functioning somewhat, and then produce a final working version of it. During step 3, what I did is I separated each part of this. So as you can see, I actually have 4 motors, but that's one of the limitations of the NXT, is that you can only have a maximum of 3. So that's one of the downsides of it. Another downside is, as you can see, the wires. Half of it, when this arm cannot fully rotate because it wraps around. It can only go about right here before it snaps off. So there are a lot of downsides of using this, but as I said, it is a prototype. From this prototype, you could probably, with enough funding and resources, you could probably make this into a great working arm. Another thing that I used is a program called Robot C, which is, it's a programming language based off of C that you can program controlling the motors in a more reliable way. So, like for this one, some of my code that I used controls both the motor, but it also controls how the direction at which it rotates. So, I'll show you that after. I also had a lot of problems with it, as I mentioned earlier. That when I first designed it, I wanted it to be, I researched a ton of projects and I noticed that, you know, some of these, I think there was one from MIT that was like a full robotic arm, you know, they had tons of money, tons of people, and I was like, that is awesome. So I tried to make what I could feel best worked, but I also wanted to go for simple. I wanted to go for the simplest design that I possibly could, that still maintained a high function. Because I just wanted it to, like I said, work and be low cost. So anybody could use it. I mean, if you use one of those ones that MIT built, it's very hard to maintain it and probably really hard to build it. This way, I know we have enough parts to build maybe 2 or 3 of these in the lab. That's another way. I feel like this project really helped me learn different things, like how to balance balance structural integrity, different things like that. Yeah. So, I guess now, I really enjoyed working at Hannibal University. It really opened my eyes. This experience taught me more than what I could imagine than from a textbook, because, like I said, I've never really worked with networking very much. I've messed with routers, but never any of the hands-on type of stuff, or worked with Windows deployment. I felt that really helped me. I can problem solve, communicate with others, and work positively with customers now, because I feel like during that, I went to parts of the campuses that I didn't even know existed. And met people that I've never met before. So I feel like that really opened up, at least for me, it opened up more my eyes to the community of the college in whole. Because I felt like I actually belong in that, you know, I feel like I can point out people's names and understand who I'm talking about and where people are. And I feel like this job really prepared me for my career later on in life. And I just want to say thank you to Computer Services for allowing me to work there this semester. Ms. Todd for helping me, sending me emails. Justin for putting up with me, asking a million questions. Mr. C for helping me come up with the idea of using the steps that, you know, make researching and doing projects so much easier. So I appreciate everything, guys. Are there any questions? Okay.
Are you gonna show us your demonstration?
Yes.
Okay. Ooh, nice.
Yeah, I added that extra little bit because if you don't have it hit the ground, I tried to first originally go all the way down and grab it by here and try to lay it down, but because there is a rod right here, it does not grab it, or because of the weight, it would tip. So I tried to loosen it up about right here so then it could grab it at the top and then set it down a little bit nicer, making it more balanced.
So does it sense whenever it touched, does it sense that it touched, or does it just,
No, it just, I have it set to where it hits I have it manually hit the ground and then it will go back up. It's a set,
okay.
yeah. But it works on every surface because no matter where, I have it to where this motor, the crane, doesn't have enough motor to actually move it. It just, once it presses against something, it kind of stops. So in a sense, it is kind of manual because, or that it senses it because after it reaches that certain point, it stops. Because it doesn't have enough force. That's one of the things that Robot C you can actually control is how much the motors actually work. So like for the arm, I set it to -20, which means that it will rotate the motor -20 degrees, or 20 degrees. And that everything I use, you can use different things like for Robot C, you can set it for rotation, angle, degrees, minutes, seconds, hours, different things like that. So I set it for seconds. So all my stuff is running off of a base timer inside. Any more questions?
How heavy of an object can you lift with that?
What I've found is a little bit less than a water bottle. And I think that is because of the motors itself. Because the motors aren't just strong enough. It's not that anything breaks off or anything like that. It's just the motors itself cannot lift it. And I've tried, that's the other thing that I tried. I tried working with 2 motors on the bottom to give it more so it can lift up things. But then, like I said, I'm limited to only 3. Because I would love to have this thing, it can actually spin around in like a 360-degree circle. But I couldn't get enough ports for it to actually work.
Does the claw was able to pick up a water bottle?
Yes.
Like it had enough grip strength?
Yeah, it had enough grip strength to lift up a water bottle. But like I said, it can only be like a quarter or less than that full. It cannot lift up very heavy objects. And it's not, like I said, it's not because of it just breaks apart and shatters and things come apart. It's because the motors themselves don't have enough strength.
Well, if we knew there was this much limitation in the supplies, why was it again that we used the Legos? I mean,
Because
because some
we
people
wanted-
would look at this and say, oh, that's a kid's project.
Yeah,
but
because we wanted to show that from this, it's not because we couldn't do it. It's because we just needed better resources to do it. That this is a prototype, and from this prototype, if we had the funding, we could potentially make a better working arm from this. That would help the lab. Any more questions?
Did someone assign you the project as for the robotic arm, or did you pick that one?
Like I said in the speech, Ms. Todd helped me pick it out. It was something that I could not come up with the topic. I researched it, but I really felt that I wanted to have a project that I knew nothing about. So I could show people that I could take a project that I knew 0 about and take it to complete and working. Because in the workforce, that's what you get assigned most of the time, is that you know very little, if anything about it, and you're supposed to take it to complete and make it working.
What's the plan for this arm? Is it gonna stay in its present form and be used in the future, or is it a kit that gets taken back apart to spare parts and then somebody rebuilds something new? And
Well, actually, even today, I got asked by Jeremy and Milos if we were going to use it because they were all excited about it. So I was going to show them how to use Robot C today, or sometime, and show them how they can use it because they were all excited about how it worked and everything. So I think it's going to help the lab a lot, get more excited about programming, which there are very few programmers in our lab right now.
I don't wanna answer your question, but it was my intent to have a robotic arm that would be somewhat permanent that we could manipulate, but again, you answered well. We don't have the resources, and rather than just buy something that was pre-made, at least we have, and so it'll probably come apart
at some
in the,
point,
down the future, because we won't be able to, it won't withstand
Yeah,
different people using it, but
but the idea is there.
do you think every CIS student should have to go through this internship experience?
Yes, because like I said, I did the external before I did the internal. So, like I said, I expect it to really be useful and that I should know a lot, and that, you know, you come in there very prideful and you think, oh, I know how to do this and this and this. And that's something that the computer field has always taught me, that you think you know everything, but then in one wave, you just know nothing. And that's what happened here. It's like, I just started from the bottom, and then you just start learning more and more and more, because, like I said, I don't think you can ever master the whole computer field. I don't think it's possible.
Now, I have worked in an internship in an external source from another company before. What would you recommend or give suggestion to me who is looking at now doing an internal one? How does it differ big? Like, what would you tell me to expect?
Networking, lots and lots of networking. A lot of cabling. You should know how to make cables reliable, reliable cables a lot. And setting up and maintaining computers, make sure you know how to, take them apart and put them back together, stuff like that.
During your research, what have you found, like in industry, and what's going on with robotics and all? How does this apply, like, to what's going on in industry right now?
Well, I didn't research that topic, but I know some things that are going on with that. That, more and more people are trying to make robotic arms to do certain things, because robots don't make mistakes. Humans make mistakes. It's less people that you have to pay, so more people are going to rely on this. And like I said, there's less mistakes, which helps companies make more profit. So this, I could see being, I don't think this type of, something that could pour something would be used, but for robotics in general, I think it's going to go a long way. Any more questions?
Thanks.
Thank you.